Okay, so today we're going to take another quick look at similar triangles. We were going to talk about yesterday how we can tell when two triangles are similar, but we'll go ahead and talk about that on Monday. So for now, we're just going to go ahead and assume that the two triangles we have are in fact similar, and then we're going to talk about how we can solve for a missing side. After today, once we actually talk about why these triangles are similar, we're going to put a lot more of the emphasis on kind of the proof side of this. How do we know they're similar before we actually start solving for x? But for now, we'll just go ahead and practice the proportional reasoning here and solving for x. So one thing I want to see from every single person on these is your proportion that you used and then the equation to solve it. And so it's your choice how you set these proportions up. There's a bunch of different ways that work. What I would encourage you to do is just get used to always doing it the same way. And so, for example, if we want to compare two triangles with each other, in the case where they're similar, we know that the sides are proportional, so I might compare the triangles as big over small. As long as I always do big over small, I'm never going to get these mixed up. Then the only thing I have to worry about is which sides match up. And so a lot of times the triangles will be laid out in an orientation where it makes a lot of sense. These two sides obviously go together, the 4 and the 3 go together. And so from there we can set it up. Big over small means I'm going to have 18 over x. And then the other two corresponding sides, 4 over 3. And I know that those two fractions have to be equal because these triangles are similar. And it just means that the ratios between the two sides are equal to each other. Now to go ahead and solve that, all we need to do is cross multiply. And so here I'd have 4x is equal to 18 times 3, which is 54. I want to see this too, so I need to see so far your proportion and your equation. Then I want to see the work to solve the equation. A lot of times it'll just be a simple matter of dividing. So x is equal to whatever 54 divided by 4 is, and that is 13.5. These are fine if you leave as a decimal. You can also leave them as a fraction, or you could simplify them. In this case, you'd have 27 over 2. Either one of those would be fine. Now there are a couple more things that can happen that kind of make these a little bit harder. So let's go ahead and talk about those. The first thing you can see is you see a lot of times triangles will look like this. And we'll talk more about this on Monday, why you'll see a lot of these. What I would suggest here is that you redraw one of the triangles. So here I have the smaller of the two triangles with the sides of 5 and 8. If I think about the bigger triangle, what sides does it have? And so the 20 down here is the 20 here. But how long is this side? And you see we have 5 here. Let's see my pointer. And x here. And so I know this thing is 5 plus whatever x is. It's got to be as long as this side plus this side put together. Now I can go ahead and write my proportion. And so I'd write this as 5 over 5 plus x. Maybe this time I'm going small over big. 5 over 5 plus x is equal to 8 over 20. Sorry about that. I'm going to do the exact same thing now. I'm going to cross multiply. 5 times 20 is 100. Now when I multiply this way, 8 times 5 plus x, I can do this a couple ways. I could write it as just 8 times 5 plus x. Or I could, if I wanted to, I could distribute ahead of time, but I'm going to go do the distributing over here. And so I would know that this would have to mean 40 plus 8x, and then I can go ahead and solve my equation. Minus 40, 60 equals 8x, 8x, and then we can just divide by 8. And again, you could do this a couple different ways. You could rewrite this as a fraction, 15 halves. You could rewrite it as 7.5. Or since the decimal is not repeating, you could go with 7.5. I personally am not a fan of repeating decimals, so I would stay away from those in math. Okay, so those aren't too bad. The nice thing about those is that the triangles will match up. So the sides that are on the same side of the triangle go together. The 5 and then the whole thing, 5 plus x. Probably the trickiest of all of these are going to be problems that look like this. And so here you have to be careful with just which sides exactly match up with each other. And so one thing to think about is which angles would actually go together. And so you can kind of see this angle here and this angle here kind of look like they're both really close to 90. And so what that tells me is this has actually been rotated. So I can see this shape here has been rotated down here. And so the X actually goes with the 3, and the 15 goes with the 4. So when I'm setting these up, I just have to be really careful with that. And so here, if I go, for example, small over big again, I could write 3 over X for the first ones is equal to 4 over 15. And that'll give me 4X equals 45, which means X equals, when I divide by 4, 45 divided by 4. I could just leave it like that. That is the simplest form. Or I could write 11.25. I would encourage you just to get used to leaving it as a fraction in simplest form. That's going to probably be your best bet. Okay, so for the rest of today, you have a worksheet to work on. So when you're setting these up, just make sure you're writing the proportions, that I see the cross multiplying, and that you're solving the equation. Monday, we'll go ahead and talk about how we actually know, for example, that these two triangles are congruent. And so it has a lot to do with the conjectures we had for when triangles are similar. So if I know those two lines are parallel, think about what I know about those shapes, and that'll help us talking about that. So I'll see you Monday.